All right, so maximizing the area of an animal pen. So a farmer has, guys, a farmer has 2,400 feet of fencing and needs to build a rectangular pen to fence in her animals for grazing. The farmer hires you to help her determine the dimensions of the pen, enclosing the greatest area that can be constructed with the available fencing. Okay, so the farmer has 2,400 things of fencing. What I want you to do at your table is take a moment and come up with possible dimensions of her rectangular fence. Okay, so when it says possible dimensions, you're telling me the length and the width of what the fencing could be. Does that make sense? Okay, the key thing to remember here is that how much fencing does she have? She only has 2,400 feet. So you have to make sure you do not go above 2,400 feet. I don't know what my pen just did. It did something real weird. Right? So you're fencing. And at your table, I want you to tell me at least come up with 3 possible lengths and widths for this fencing. Okay? 3 possible lengths and width. All right, let's see where we're at. Claire, what did your table come up with as a possible dimension? 500 by 700. All right, I'll take it. All right, Anthony, did yours come up with a different one than 5 by 700? We have an 800, 400.
Oh, we have 700, 500.
We got that one. We got a different 300, 900. Okay. We have a 300 by 900. What did you guys get?
1,000 by 200.
A 1,000 by 200. Okay. Any other groups come up with anything else? What'd y'all get, George? What's your length and what's your width? All right, so we have a 600 by 600. Anyone else? A square is a rectangle. It's a perfect rectangle.
1100.
There we go. It's a very it's a very, you said it, I didn't hear you say it. I heard 1,000 by 200. Okay. Are there any more? What did you notice as you were doing this? You had to find numbers that did what? That fit, but what is a pattern?
You didn't say rectangle, I think you have 600.
A square is a perfect rectangle. You should have learned that in geometry.
Wow, you're lying.
A square is a perfect rectangle, sir. Okay. The definition of a rectangle is a quadrilateral with two pairs of parallel sides and 90-degree angles. What is a square? What is a square? A quadrilateral with two pairs of parallel sides and 90-degree angles. All right, so here we go. One thing I would like for you to realize is that your length plus your width has to equal 1,200. Does that make sense?
Yes, ma'am.
Because your length and your width only represents half of the fencing. And what's your total amount of fencing? 2,400. So if I know half is 1,200, then the other half obviously is also 1,200. So that's something you could have came up with. Or if you went through and just literally added up and labeled all the sides, that works perfect as well. Okay. Now we're going to somewhere. There's a box. There was. I don't know where. On my desk. Somewhere. Or right there. All right, so now we're gonna make a table, a 3-column table with width, length, and area of the animal pen, okay? So we're gonna write the values that we came up with from our sketches into there. Shh, guys.
We were talking about the rectangle and square argument.
Okay. Here we go. So we're making our table width, length, and area. So if we have the width, we have our length. I don't know why I put an extra line there. And we have our area. So it wants us to make a 3-column table classifying these. So when I look at this data, I can put this in some type of order, right? I can put it in order by length. I can put it in order by width. I'm just going to go in numerical order. I'm going to do 100, 200, 300, 400. So we have 100 was at 1,100, right? We have 200 and 200's at 1,000. We had 300 by what? 900. We had a 400 by 800. We had a 500 by 700, and we had a 600 by 600. Do you see a pattern now?
Yeah.
You'll see it? Okay.
It goes down like.
So it's going down, but they are pairing up together, right? The entire time. Would it matter if my length and my width value switched? No, it would not. It just would change the direction of my pen. Does that make sense? It would not matter if I switched my length and my width. Okay. Next is to calculate area. Remembering area equals length times width. So what would be the area of my 100 by 1,100? 110,000. Or I can just write it as 110K. Is that okay? If I just write it with the K? No one will freak out on me? Someone will. Without. All right. So then it says 200 times 1,000. What's that's going to give me? 200,000. 300 times 900. 270,000. Okay, then we have 4 times 8. 320,000. I don't know why. 500 times 700. 350,000. And last but not least, 600 times 600 is 360,000, right?
Miss, our low key ran out.
You can use the bottom part. There's nothing that's going in there. All right, so we're looking at our values as a class. You can see the problem. You were supposed to be doing parts 1 and 2 completely by yourself, and we were supposed to come back together. However, we need a little more guidance still before we work more independently, okay? It's okay though. So we've already shared our values with our class. We come up with a conclusion. So looking at this chart, could we tell her what the best dimensions for her to get her maximum area would be? Her best dimension would be 600 by 600.
Wait, why?
She wants the most amount of area for her animals to roam in.
Even if it wasn't an individual thing. You are like the most brainly.
Oh, it's okay. We're here. We're all here together. All right. So when we are determining this, if these numbers weren't as friendly, right? What if we didn't have as friendly numbers? What if the numbers were decimals or larger numbers that we couldn't easily manipulate visually? How could we solve this? Well, this says to use decimals. We're not going to use decimals. We're going to keep using our 84s because when you go to college, when you take your ACT, when you do your placement exams, guess what you don't have? Decimals. So why would I have you practice decimals when it's not a tool that would be always accessible? What is a decimals? A waste of time. You're right. All right. So we're going to go back over our steps of how to do it in our calculator, right? So in our calculator, step 1, you should always reset your calculator. How do we reset our calculator? There we go. Second, plus. Do we really?
Yes.
Well, then we'll stop.